Hi, my name is Suhan Merot, and behind the camera we got Neer Patel and Amol Shankar. And for number one, the resting membrane potential has a charge imbalance where the outside is relatively more positive. It shows a steady state of the cell, which is a dynamic process that is bound by ion leakage and ion pumping without any outside influence. It is measured by the charges inside and outside the neuron. For number two, an action potential is an all or none event because it has to reach the threshold potential. If it does not, the membrane potential goes back to the resting state, which is negative 70 millivolts.
Go.
My name is Alok Shankar, and for number three, when a nerve impulse reaches a neuron, the sodium channels open, causing an influx of positive ions to enter the cell. This rapidly makes the inside of the cell relatively more positive, which depolarizes the cell and creates a signal. This is because there's a higher concentration of sodium outside and a lower concentration inside. To repolarize the cell, sodium channels are closed and potassium channels open, letting the high concentration of potassium ions inside the cell go outside the cell. The closing of the potassium channels are delayed, hyperpolarizing the cell, and then the sodium-potassium pump cycles the sodium and the potassium ions to bring it back to the resting potential.
Hi, my name is Neer Patel. For number four, the action potential propagates along the axon because more voltage-gated Na+ channels are open as the depolarization spreads, and the sodium ions enter through the channel and move along the inside of the cell membrane. Between myelinated axons, sodium ions that enter the channel at the initial segment start to spread along the length of the axon, the segment, but there are no voltage-gated Na+ channels until the first node of Ranvier. Between unmyelinated axons, the propagation is referred to as continuous conduction, where sodium ions rush into the cells slowly